Hey everyone, welcome back. In our last video, we learned how to use bash to list, organize, and secure our log and config files. Today, we're taking it a step further by analyzing our logs for suspicious activity. In this demo, we'll search through our log files for failed login attempts, extract the source IP addresses, and even count how many times each IP appears. I won't be diving too deep into each of the commands, but rather showing the basic examples for each and how they work together. Let's dive in. The following is the scenario for today's lab. In Linux, you have a log file that records SSH login attempts on your system, which is located in /war/log directory. The file is called auth.log. In this example, however, we will use auth.log file obtained from Elastic's GitHub examples section. You can find the link for the file in the description below. The goal of today's exercise is to identify and count failed login attempts to spot potential brute force attacks. To begin, let's download our log file using wget command. Now that the file is downloaded, the first command we're going to go over is cat. Cat is short for concatenate. In your terminal, type cat and then the name of the file you want to output. In this case, it's auth.log. This simply prints every single line of the file to your terminal. Not really that useful considering there's probably a lot of lines. We can see how many lines the file consists of by using wc-l. wc stands for word count and -l tells it to count lines rather than words. For cat to work with wc, we have to use pipe symbol, which is kind of like a vertical line. And once we put the pipe symbol, we can type in wc-l, just as you see on the screen. So what pipe does is it takes the output on the command on the left side, cat in this instance, and it passes it to the command on the right, wc-l in this case. So here it takes the printed lines produced by cat and sends them directly into wc command. And as you can see, we have 7,121 lines. Alternatively, we can also use awk. Awk is abbreviation for Aho, Weinberger, and Kernighan, which are the last names of its developers. Awk is a powerful text processing tool that splits each line into fields or columns based on the separator, which by default is white space, but you can use other separators as well, such as comma, semicolon, and so on. Awk has the following structure. It's awk command followed by operation. So let's say print, and then by the file name. It literally does the exact same thing as cat. However, this is a very, very, very basic example of awk, and it's so much more powerful than that. We could also use awk to isolate lines in our log that indicate, let's say, a failed login attempt. We can do this in the following manner. Failed password. So /failed password / followed by the operation will only extract lines that contain the string failed password. Each line here contains that string. And if we pipe this again into WCL, notice how much less lines we have. In Linux, there are many different alternatives of terminal commands that can achieve similar results. We can also search for failed login attempts with grep. Grep is a tool that's used to search through the text for specific patterns. So we can do grep, failed password, and then file name. One thing I kind of do like using grep more than awk in this specific use case is that it actually highlights the string that you are searching for in the line. It seems like the command is pretty straightforward, however, I will go over it nevertheless. So first we have the command itself, then we have the string we are searching for, and finally we have the file name to search for. When you run this command, grep scans every single line of the log file and returns only those lines that contain the phrase failed password. It quickly filters out irrelevant information, letting us focus on potential brute force attacks or unauthorized access attempts. We could also combine grep and awk to work together. Let's build on the grep command using awk print $11. So print11 tells awk to output the 11th field from each matching line. And as you can see here, I forgot to put the name of the file, so that wouldn't work, would it? The idea for me here was to extract only the IP addresses. Well, after filtering the log for failed attempts, you likely want to know which IP addresses are causing these failures. In many log formats, the source IP address appears in a specific column. In this case, we assume it's the 11th field. Depending on your system's format, the IP addresses might be in different fields. You may need to adjust the field number accordingly. So how come we have what seems to be IP addresses and usernames? Well, let's go back to auth.log itself to figure it out. A few things stand out to me here is, first of all, we have failed password attempts for invalid users. Do we care about invalid users? Yeah, perhaps we do, because that may indicate password spraying attacks. We also have another entry which seems to aggregate various attempts into a single log entry. As you can see here, message repeated 5 times, and it's the exact same message as I believe here. So we can go about this a few different ways. We can either filter out invalid users and filter out the repetitions. That should give us the 11th field, I believe. So let's try this. We can achieve this by using grep -v. -v eliminates lines with certain string patterns. So in this case, let's use message. So this line contains message, and we can use invalid to eliminate the following lines. So curly bracket, print 11, close curly bracket. This gives us the output of only IP addresses. So field number 11 seems to work well with that particular line. Our other option would be to focus on repeated, considering if it's not repeated, perhaps it was just the user's mistake. But repeated, that means that perhaps something fishy is going on. So let's grep repeated. And here, let's see, 1, 2, 3, 4, 5, 7, 8, 9, 14. I believe field number 15. Print 15, so 16. I was one off. And these are the repeated IP addresses that are trying to log in to our server. In terms of awk, alternatively, you can achieve similar result as print 16, for example, with cut command. So here we can use cat-d f16. So cut command has 2 flags, which is D, stands for delimiter. Delimiter here would be a space, and F tells it which field we want to separate, in this case number 16. As you can see from both command chains, awk and cut, we have quite a bit of repeating instances of the same IPs. To combat that, we can use 2 other commands, which is sort and unique. Sort organizes the list of IP addresses alphabetically or numerically, which groups identical IPs together. Unique-c then counts the number of times each unique IP address appears in the sorted list. But because we are already grepping for repeated, that does not really matter in this particular scenario, because it's already aggregated by the log itself. However, if we use the same in this scenario where we grab the message and we grab the invalid, and we are just printing the valid username attempt, we can use sort and unique C. And this actually gives us a better picture of which IP addresses are potentially being used to brute force our server. We can build on this by enhancing readability with Sed. We will also use tr for making the IP into a nice comma delimited list. We'll start with the stream editor, or Sed for short. So let's do Sed quote s / array / suspicious IP / and closing the quote. Let's break up this command a little. So here, S tells Sed that we want to perform a substitution. Array, aka the arrow pointing up, represents the start of the line. So what happens is that Sed looked at the beginning of each line because of the array and replaces that quote-unquote empty space at the start with a string suspicious IP. The forward slashes throughout the command act as delimiters that separate the different operations. This command helps to make your output self-explanatory, labeling each IP address for clarity. Well, not really, because as you can see, we removed the sort and unique. So now we just have a bunch of repeating IPs. So if we go back and type in sort-u, which is alternative to using sort-unique and count, this should aggregate all of the IPs. However, we do lose that little count at the beginning. So let's go back and do sort pipe unique -c. So we have that little count. Oops, so if we do that prior to Sed, we have the count here, which does not really help us. So let's put the pipe after Sed. So we have the count in the front. This command helps us make the output a bit more self-explanatory, labeling each IP address for clarity. Some homework for you that I may suggest is, you see how here we have count 1, count 1, count 1, count 3. Maybe write a bash script that excludes all of the IPs with count 1 and only leaves the IPs that have count of greater than 10. Well, now let's move on to TR, which stands for translate. We'll bring it back to auth, which pipes into sort unique C. Actually, you know what? We will remove the unique C and just do sort U. We have all of these suspicious IPs, right? Let's say we want this whole output, without investigating further, to put into some sort of security tool that only accepts input as IP separated by comma. We can use translate as the following tr, and our first entry would be backward /n. It stands for invisible new line right here. And we will translate it to comma instead. See, now we just have a nice list of IPs that is separated by commas, and we can put that as an input into your relative security tool, let's say. Well, that's a bit of text transformation and text analysis for you using Bash. Lastly, let's save the results of one of the commands into a new file using redirection operator, aka an arrow sign pointing to the right. Yeah, we'll just save the output of our last command. You literally just type in the arrow sign pointing to the right and a file you want to save it to. Let's say iplist.txt. As you can see, our file was saved right here. Saving the output is essential for documentation and further analysis. That way you can review the file later to see which IPs repeatedly attempted to log in, or even use it as an input for additional scripts. For example, to block those malicious IP addresses automatically. This is it for today's session. We went over some basic techniques that you can use to analyze logs for suspicious activity using bash commands like grep, awk, cut, sort, unique, sed, and finally tr. By chaining these tools together, we were able to filter out failed login attempts, extract IP addresses, and even count how many times each one appeared, giving us a better picture of potential brute force attacks. Although not yet scripting, this is a great example of how chaining various commands can make log analysis faster and more efficient. Instead of manually sifting through thousands of log entries, a few crafted bash commands can do the heavy lifting in seconds. Plus, we saved our results to a file, making it easier to review and take action against a potential threat. In the next video, we'll shift gears and start looking at the structure of bash scripts and key scripting elements. Understanding how to build scripts will further strengthen your automation skills, allowing you to streamline security tasks. If you found this video useful, be sure to like, subscribe, and drop a comment below. Let me know what other bash topics you'd like to see covered in this series. See you in the next one.